Now, previous class, we were learning about the concepts, the basic terminologies of the probability theory. Now, probability theory is the number of chances, the number of possibilities that can come out of an experiment is called as a probability. Okay, the outcome of the event will become a probability. Now, under that, we have to understand few basic terminologies. Out of the basic terminologies, the first one is the sample space. Now, sample space means all the possible outcomes that you can see. Now, because of pollution, what all effects can happen? What are the possibilities? People will get new diseases, respiratory diseases can happen to the people. Now, this COVID-19 is happening, which is a part of respiratory diseases, cold, influenza, dust allergy. So you have so much list, right? Okay, all this will become a sample space. So the set of all possible outcomes of the experiment is called a sample space, and it is denoted by S. Now let us see a few examples. Now when we toss a coin, the coin will have two faces, that is, one is head and other one is named as tail. So the sample space of tossing one coin is either a head or a tail can come. So those are the two possibilities. Okay, when you write an exam, what can be the outcome from the exam? Either you can pass the subject or you can fail the exam. So there are two possibilities. So the sample space in that situation is pass or fail. When we are able to count the number of possible outcomes, it is called as finite sample space. And when we are not able to count the sample space, it will become infinite sample space. Okay, now let us see one more example. 3 coins are tossed. It is not one coin, but it is 3 coins which are tossed. Now, when the 3 coins are tossed, what all can be the possibility? So, 3 coins are tossed. Okay, so I can have the possibility of all the coins having head. You play that rock, paper, scissors, right? You play hand cricket. So what is the possibility of everybody in rock, paper, scissors? What is the possibility of everybody, opting for a rock or everybody opting for a scissor? Similarly, 3 coins are tossed, and what is the possibility of a coin? The coin can give you head or tail. So in the first scenario, when I toss a coin once, let's say I am getting a head. All the 3 coins I am getting head. Okay. Now next time again I will toss a coin, and this time I will get head, tail and tail. Okay. First time I will get head. Second time I will get tail. For the second coin and the third coin, I'll get tail and tail. Now again I will toss a coin. This time I will get tail, head, tail. First coin I'll get head, tail and then head, and then third coin again I will have a tail. I am tossing the coins together. 3 people are standing and they're tossing the coins at a time. So the first person is getting tail, the second person is getting head, the third person is getting tail. Again we will toss the coin together. Tail, tail, head. This is another possibility. Okay, and then you can have tail, head, head. You can have tail, head, head. You can have head, tail, head. Right? You can have head, head, tail. First 2 coins can be head and then it can be tail. And then you can have tail, tail and tail. So if you see here, I've got so many possibilities. 1, 2, 3, 4, 5, 6, 7, 8 possibilities I have got when I have tossed 3 coins together. Okay, when I've tossed 3 coins together, I've got all this possibility. So this is known as a finite sample space. Because I can count there are 8 possibilities here. So it is called as finite sample space. Now, did you all understand this part? Did you all understand the first terminology? Okay. Now, that was finite sample space. Now, let us understand infinite sample space. Now, infinite sample space means, let's take for example, Orion Mall. Now, Orion Mall is such a huge mall. Can we count the number of customers that comes on a daily basis? Can you manually count? It is very difficult to manually count. Okay, there is technology of how many people are coming and going. Technology is there, but still you cannot perfectly say. But we are trying to manually count the sample space, which is not possible. So that is called as an infinite sample space, where you're not able to count the outcomes that comes from the experiment, or that comes from one particular example. That is called as infinite sample space. Okay, now going on to the second definition terminology, experiment. Now, whenever they do a experiment, or this is also called as random experiment, this is conducted repeatedly. Now, if you see the tossing of the coins, we tossed the coins 8 times and we got 8 different results from it. So, the tossing of a coin together was an experiment. The 3 of them stood there in one place and they kept on tossing the coin. So it's a random experiment which is conducted repeatedly under essentially homogeneous or similar condition, and the result is not unique. The result of the experiment is called as outcome. Now, what was the possibility between when they toss the coin? Either a head or a tail. Nothing more than that you can get. Right? You cannot say the coin will stand like this, where you will get neither head nor tail. No, we are not considering that part. We are taking either it's a head or it's a tail. Now, an experiment or a random experiment is such that it is repeatedly conducted under a similar situation or similar condition. Now, we kept on tossing the coins. They were standing there for some time and they were tossing the coins. Okay, so that is an experiment which was conducted. Okay, so that is an experiment. The next one, the outcome or combination of outcomes are called as events. Now, outcome, one of the outcome, the result of the experiment is called as outcome. Now, when I toss a coin, head or tail is the outcome. If I get head, that is an outcome. If I get tail, that is an outcome. Okay. Now, when we toss 3 coins together, the possibility which we saw of head, head, tail, head, tail, head, tail, 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 all the 3, those will be the combination of outcome. I am combining 3 events, or I am combining 3 different things that is happening, and that will be called as events. So events are denoted in capital letters, something like A, B, C, D, etc. And their outcomes are denoted by the small letters. An event without any outcome is a null event. This you will have to remember. Null event is written like this. Put a 0 and scratch that 0. One line. Don't scratch it too much. One line on that 0 is called as null event, which means there is no outcome for that event. Okay. The denotion of null event is like this. And the outcome, since there is no outcome for the null event, we can write it as 0. So that is an event. Did you understand the experiment and event? Any doubts in the experiment and event? Did you all understand until here? You want me to repeat any of this? Okay. Next, an event with only one outcome is a simple event. Whenever there is a head or a tail, that is only one outcome. When you toss a coin, you will either get a head or a tail. Okay, when you roll a dice, you will get only one number. You cannot get more than one number, right? So that is a simple event. No complication, very simple, you will get the result. But if there are more than one event happening at a time, that is called as compound event or composite event. When if we are tossing 3 coins at a time, if we are playing with more than 2 dice, we are rolling 2 dice. If we are playing with the cards, so many cards at a time, that will become a compound event, or it is also called as composite event. An event containing all the outcomes of a random experiment is a sure event. It is called the sample space. Now we understood what is a sample space. The other name of sample space is sure event. Okay, now let us see the example. Tossing 3 coins at a time, A is an event of getting 3 heads. So we will say one possibility of tossing the three coins. We will denote it by a capital letter, and we are saying we will get a 3 heads in that. So this is a simple event because only one possibility we have considered. Okay, and then B is an event of getting 2 heads. 2 heads means heads and tails. HHT if you get, that is also a simple event. Okay, wait. B is an event of getting 2 heads. So what all the possibility you can get? Heads and tails. Head, tail and head. What is the possibility? 2 heads should be there. So you have 2 heads and the tail, then again 2 heads and one tail, then again 2 heads and one tail. So there are 3 possibilities which you can get. So when you have more than one possibility, it will become a compound event. I'll repeat it again. We are tossing 3 coins together and the possibility of getting 3 heads together. There is only one possibility of getting all the 3 heads. So that will become a simple event. Okay. But if I say possibility of getting 2 heads at a time, so which means 2 heads and one tail will be there. Correct? So here coin number 1, 2, 3. So 1 and 2 is having head. In the next possibility, 1 and 3 is having head. In the next possibility, 2 and 3 is having head. Okay, this will become a compound event. And finally, for the null event, compound event C is an event of, okay, this is a compound event, there's a full stop, and then C is an event of getting 4 heads. Now, when we are tossing 3 coins, can we get 4 heads? There is only 3 coins and you should get only 3 heads. You cannot get 4 heads. So that is a null event where there is no outcome. Since there are no 4 coins, you cannot have 4 heads, and that cannot be a event. So that there is no outcome for that event, then it is called as null event. Understood? Did you all understand till here? Now, next one, favorable events. Now, favorable events means whenever the result or the outcome of the event is all favorable to us or favorable to the situation. Okay, then in that case it is called as favorable events. The outcomes when they occur or when they occur with the event with the favorable outcomes. Now let's take an example. In a toss of 3 coins, the number of favorable outcomes to the event is exactly 1 head. So if I get exactly 1 head, then I will be able to win the game. So at that time what will happen? I will see what all are the possibility where I can get exactly 1 head. So which are the possibility? Head, tail, tail, and then tail, head, tail, 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 head. So in all the 3 possibilities, you only have 1 head which has been there. So this is the favorable event where we are getting the answer for the question that we require, that question that we asked. Okay, so the outcomes of the event will be very favorable to the situation or the very favorable to the event. Next, exhaustive events. The set of the total number of possible outcomes of a random experiment is the exhaustive event. This is something like a sample space. Okay, what all are the possibilities that can happen when I toss 3 coins together? We got 8 possibilities, right? So that can be a exhaustive events. So if a coin is tossed once, the outcome is head or tail. Once 1 coin I am tossing, and what is the result I will get? Head or tail. Okay, so what is the exhaustive cases? 2 cases. Either it can be a head or it can be a tail. Okay, so how will I know? Then the exhaustive cases will be 2 to the power n. Then if I roll a dice, now the dice when I roll, if we are playing snake and ladder or ludo, and if I roll the dice will have 6 numbers. Okay, so the outcome, the result can be any number from 1 to 6. So there are 6 exhaustive cases here. Okay, one time if I roll, I get any one number out of 6. Correct? If I roll it for 2 times, I can get any 2 numbers between 1 and 6. Because I am rolling it 2 times. First time I will roll, I will get 1 number. Second time I will roll, I will get a different number. Right? So, if I roll it for n times, then the number of cases will be 6 to the power n. Now let us see with another example. Now the 3 coins were tossed, or we'll take 1 coin 3 times. That will be easy. If a coin is tossed for 3 times, I am having 1 coin only. I am tossing it for 3 times. Okay. Now what can be the outcome of it? So if I toss it for n times, I should get 8 possibility. How is that? 2 to the power 3. N is 3 times I am tossing. So I will get 8 possibility. So what are the possibilities? I can get head all the 3 times. I can get head once, tail and tail the second time. I can get tail first and then head and then again tail. I can get all the 3 times tail. So like this, I can find out the possibility. So that is the exhaustive event. Total number of possible scenarios that can happen for an event. Okay, so that is exhaustive event. Next, mutually exclusive event. Now in mutually exclusive event, if the occurrence of one event excludes the occurrence of all other events in a single trial, then it is called as mutually exclusive. If one event is happening, we will only focus on one event and we will not consider the other event. That is what they are trying to say. If occurrence of one event excludes the occurrence, it is leaving out, excludes the occurrence of the other event. Now, if at all we have P into A plus B, here A event is separate, B event is separate. Okay, just because we have written A plus B doesn't mean they are together. Fine. So example, in a toss of one coin, the events head and tail are mutually exclusive events, because if head appears, tail will not appear. If tail appears, head will not appear. Correct? Once I toss a coin, I will either get head or tail. I cannot get both together. So that is called as mutually exclusive events. If acceptance of a situation means rejection of the another. Now let's say we are going for shopping and we will see two white shirts. Now out of two white shirts, on one shirt, let's say one of the shirt is A and the other shirt is B. Okay, one shirt is A and the other shirt is B. You want only one white shirt. Okay, now on the A shirt, A is a pure white shirt and B is a half white shirt. You know the difference, I believe. There is a very, very slight difference when it comes to these colors. Okay, one is a pure white shirt, the other one is a half white shirt. Now, what will happen is you want to buy only one shirt. You don't want two or three. Okay, so what you will think, okay, you will accept the pure white shirt, which means it implies that you are rejecting the half white. You are rejecting the B shirt. Acceptance of A shirt means rejecting of the B shirt. This is called as mutually exclusive events. Okay, if you get head as the answer, you cannot get tail. If you get tail as the answer, you cannot get head. That is known as mutually exclusive events. So did you all understand mutually exclusive events? Another very important topic or the terminology which will be used throughout. Understood mutually exclusive? Okay. Now next, equally likely events. See, these can be asked for 2 marks question. Apart from that, they will give you one 14 marks question or 6 marks question asking you to explain about the different types of events under probability. We will be using all of these terminologies in solving the problems. Almost everything. So let us see now. Now next we have equally likely events. If the events have an equal chance of occurrence, then they are called equally likely events. The probability of these events are equal. The events head and tail in tossing a fair coin is called as equally likely events or equiprobable events. So when I toss a coin, tossing a coin is the best example in the probability. When I toss a coin, there is an equal chance of getting head and also an equal chance of getting tail. Sometimes you will write exam in great spirit. Okay, now after coming back from the examination, you will go through the question paper once again and you will realize, okay, now after seeing the question paper for the second time, there is equal chance of me passing, but there is also an equal chance of me failing in the examination. That will be your thought process. That is called as equally likely events. Okay, you are having a fair chance of getting heads or you have a fair chance of getting tail also. Okay, so that is equally likely events. Then independent events. If occurrence of one event is not affected by the occurrence of the other event, then it is called as independent events. Okay, now let us say we have you people would have played Uno card and all, not Uno card, right? Now drawing of two cards from a pack of cards. Now here the pack of cards is not your Uno cards that we are talking about. These are the cards where they actually use in the casino or gambling purpose, where they keep money and play, right? That rummy.com, whatever you have those cards. So that cards they are talking about. We are just here to learn how those work. It's not that we have to play it. We are just learning how those work. So in drawing two cards from a packet of cards, one after the other, with the replacement of the first drawn card, then the event of drawing a card in the first draw is independent to the event of drawing the card in the second draw. Now easily how we can understand is, let us say we have a bucket which is full of marbles. Okay, we have a bucket which is full of marbles, colorful marbles we have. Let's say black, red, orange, yellow, blue, all marbles are there. Now we will take one marble and we will see randomly, we will pick one marble, and let's say we have got black marble. Okay, now first time we have got black marble, we will put the black marble back into the bucket. Okay, now again we will mix and we will randomly take another marble. Now this time let us say you have got an yellow marble. Okay, so these two are independent events. Here me selecting a black marble for the first time and selecting a yellow marble for the second time was nowhere related. I randomly selected some marble and I put it back into the same bucket and I again chose another marble. So these are independent events in the probability. Understood? Equally likely events and independent events. Any doubts until here? Okay, next, dependent events. Now, dependent events, what will happen under dependent events is, if I am taking, if I am selecting one object for the first time without replacing the other one. Okay, let's take for example, now we have gone for shopping once again. We'll keep going for shopping a lot of times here to select the lot of dresses. Okay, so we have gone for shopping. Now in that shop, you have bought a very good blue color top, shirt, t-shirt, whatever you want, you can imagine. Okay, you have bought a nice blue color, you have selected a nice blue color shirt, t-shirt, anything. Now you will not put that back, you will not leave that there. For that blue color top or t-shirt or shirt, you want to find a pant. Okay, now one is dependent on the another. So the first draw, the first time selection is dependent on the other selection. Now for that blue top, you want a matching pant or something, contrast or matching, something you wanted to buy for that. That second time whatever you buy will be depending upon the blue top or shirt. That is known as dependent events. Occurrence of one event will affect the occurrence of the other event also. Now going back to our same marble example, first time when I picked up the black marble, next time let's say I will pick up an yellow marble. Why did I pick up an yellow marble this time? This time I saw, okay, yellow and black are combination. Again I will pick up a black marble. Now yellow, black, yellow. Now again I will take an yellow, add it to a, take a black. I only am selecting yellow and black, which is dependent on each other because I wanted that combination. They are dependent events. I am not replacing anything. I am not putting back the blue shirt. Keeping the blue shirt, I am selecting the pant for that. That is known as dependent events. And then the next important terminology is union of events. Now, in union of events, it's occurring of at least one of the events. The event of occurrence of at least one of those events is called as union of events. It is denoted by U or plus. In tossing 3 coins at a time, A is an event of getting 3 heads, B is an event of getting 2 heads, then A union B is an event of getting at least 2 heads. What are they trying to say? Let us understand. In tossing 3 coins, again there are 3 different coins which has been tossed. Now A is an event of getting 3 heads. 3 heads means when I toss, I will get head, head and head. B is an event of getting 2 heads. 2 heads means head, head, tail, head, tail, head, tail, head, head. In all the 3, I have only 2 heads. Okay. Now, if I want to find out A union B, this is union of events, A union B, then I will have to see, I'll have to add all of this possibility. Head, 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 tail, head, 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 and head, head, head. Now, how do I represent this? How do I say it in a statement form? In the statement form, I will say event of getting at least 2 heads. At least means minimum 2 heads you should get. So if you see this A union B, see there is minimum 2 heads. Minimum 2 heads. Minimum 2 heads and minimum 2 heads. Right? So this is called as at least feature that we will be adding to the union of events. So the minimum number of the heads here will be 2 heads. Did you understand union of events? Any doubts until here? The basic terminologies of the first 10 terminologies is understood? Okay. Now moving further for the intersection. Now we understood union. Union means we are adding everything. We are seeing all of the events together. Now intersection. Intersection means always remember what is common. Okay, what is common, we will check that. Now, the event of occurrence of both the events is called as intersection. It is denoted like this and X. In tossing of 3 coins at a time, A is the event of getting 3 heads, B is an event of getting more than 2 heads, then A intersection B is occurrence of both the events. Okay, so if A is an event of getting all the 3 heads, which is nothing but head, head and head, and if B is the event of getting more than 2 heads, 2 or more. 2 or more means again I will have same HHT, HTH, THH, and what else? HHH. Okay. Now in both of this and this, what is common? All the 3 being head is common. This is called as A intersection B. What is the common thing which is occurred in both the events is called as intersection. Okay, so that is the intersection of the events. And next is complement of an event. The non-occurrence of a particular event is called as complement of an event. It is usually denoted as A dash, a small dash or a line here like 1, which is nothing but S minus A. Now complement of an event is like whatever is not happening, that will be included in the complement of an event. If I toss three coins, and if I am thinking of getting two heads, if I'm thinking of getting two heads, then what, apart from the two heads, the other possibilities are complement. Okay, even more simpler, if I toss one coin, what can be the result? What can be the sample space? Sample space is head or tail. If I toss one coin and I am expecting to get head, okay, the tail will become the complement. This is non-occurrence. I got head, so that is why tail will become the complement. The non-occurrence of the particular event. Understood? Any doubts still here? These are the basic terminologies which are very important to be understood and remembered. Any doubts? Okay, we'll stop it here for today. Tomorrow we will continue with the rest of the methods and we'll also solve the problems. You might have few sudden classes like this, so please do adjust and attend the classes. Okay? Yeah, thank you, students.